going to do this using mental math. Here's your first set. I want you to try to find a strategy that isn't adding and then dividing to get the average. Do you have a volunteer to tell me what they think the average is and how they got there? Ben?
That's mine.
Oh, that's good.
I did the add.
You added them? Okay, Greta?
30.
Okay, and why do you think it's 30?
Because I added all of the values together.
And divided by 3?
Divided by how many.
Okay, did anybody do something different that where you didn't have Ellery?
Well, it's 30 because those two balance
Yeah,
each other out.
the 3 below and the 3 above would kind of cancel the distance away from 30, right? So in this case, our median, 30, is also our mean. And we didn't have to add really much, okay? I want everybody to try that strategy with this next set. Try that same strategy with this set, please. Okay, using that same strategy, is there a volunteer to tell me what they think the mean is? Abe, what are you thinking? 81. Explain to me how you're seeing that.
Because it goes up 10, 9 going up.
Yeah, okay.
And then it goes down 10 and down 1.
Yeah, so it's 81's kind of split in there, right? Do you guys remember yesterday when I was encouraging you with you were putting in at least 10 data sets, and I said put the median in and then like stack with purpose? Do you remember kind of that thing? So to keep the average 10, if you put a 12 above, you put an 8 below, and so on. You put a 15 above, you put a 5 below to keep same distance away. So that gives us, what's another way we can describe this distribution? The mean and the median are the same. What's another way we can describe our distribution with this data? Where it's like the same on both sides. What is it? Yeah, symmetrical, right? There's symmetry across our median. So next set, try to do the same strategy. See if it can work as well, not as well, or if you need to do something else. All right, who can tell me what the average is and how they know? You can on this one even, I would add divide.
It's still 100.
The median would be 100, the middle value. But that if there's that 0 there, can the average be 100? Okay. What do you think, Sam? 50, okay, because you're seeing it pull down the hundreds is kind of what you're seeing. I'd say 50 would be right in the middle of 0 and 100. Okay. I got 80. Anybody else seeing 80?
Yeah.
Well, if I add them together, I have 400 divided by 5 is 80. I think another way we could see this, is to make this 0 and all these the same. I could do 20 away, 20 away, 20 away, 20 away, 20, 40, 60, 80. So 80 is the average. Now, here's the question I'm going to ask. Up here, 30 worked as the median and the mean. Okay? Is that a good explanation of the middle of the data? Okay. Here, 81. Was that a good explanation of the middle of the data?
Yep.
Okay, the average here was 80. Is that a good explanation of the middle of the data?
No.
No. The median would be 100. Would that be a good explanation of the middle of the data? 4 of them are 100. Okay. Last one. Try to use a similar strategy to see if you can get that average mentally. All right, Natalie, what are you thinking? You got an average for me here? So let's take a look. It's been working if it's the same on both sides. Up 1, down 1, check. Up 6, down 6, check. Would you guys think that 6 would be a good number for the middle of the data?
Yeah.
So, what I'm going to point out is symmetrical for 1, 2, 3 of them. The mean was a good middle. Skewed left, the mean was a bad middle. Just keep that in mind as we're rolling through today, all right? This was with intent. Is the mean or the median the better middle? So I'm going to give you a card sort. You're going to do this like you did the other day where you take turns. One person, one person, one person, one person. Not just laying them all out. You're going to have a discussion why you think it is right. You're going to see multiple representations and you're going to get different information to compare. When you finish number 1, I want you to stop. We're going to make sure all of our piles are correct before we move on to number 2. I'm going to start revealing our matches. So, here's A. It's symmetric, bell-shaped, and the average is 6. Are we good with that?
We got it.
AI.
Allen Iverson.
Played for the Pistons, but mostly the 76ers.
Wait, it's supposed to go with the
No, this is it.
The shiftiest crossover in history.
Okay, here's B.
That's Kyrie Irving.
No, it's not.
Here's B. Now this one, it doesn't say symmetrical, but it is. This one shows a mean of negative 14 and a MAD of 2. So interpreting that MAD of 2, what that's telling us is, on average, our data is 2 away from the average, which means, what do you think? Means close or far away? I think it's pretty close. And it's really important to compare it to this one. This one has the same average, so check it out, back and forth. This has an average of negative 14. A lot of our data is close to negative 14. This one has an average of negative 14. Is our data close to negative 14? No, so look what happened on average. It's 5.2 away. So you didn't need to calculate the MAD to interpret the MAD. It's on average further away from the mean. What's up, Sam?
We have C or A.
Yeah. Should have had them.
This one is just blank.
Well, there could be a blank one. I don't have anything rolling around in here, so if anybody has extras, get in the sand. Okay. Anyway, if you have extra cards. Okay. So let's compare now D. We have a median of 11. You can see that the middle wants to be right around here, right? But it's skewed to the right. What would that do to our mean? And make it right. It skew it right. Okay, here, our median wants to be somewhere around here, 14 and a half. But this data does what? Skews it left. Okay. This is the only one that this can be uniform. Notice all my quartiles are the same.
Yeah.
Okay, and the median's negative 14. Now, if I did not have this card, can I just look at this box plot and say uniform? No, because we don't know specific data points. We could have a collection of data like this stuff in here could have 2 or 3 on each one, but a quarter of it's still in there, right? This just splits us up in quarters. What would we need to see if it's uniform? A dot plot. Even a histogram, we don't see specific points. We need specific points. And then this one, our interquartile range, looks like 25 minus 14-ish, 11, okay? And then see how this is so big over here? There's data over here that's kind of out there pulling my average higher. So what we have here, we already just talked about all that, but I'm going to go back to this to problem number 2. So what we have here is a situation where our center kind of wants to be 2 different places. So I want you to make 2 different stacks out of your cards. One stack where the mean is the better measure of center, and one where the median is the better measure of center. So 2 stacks. A stack where mean is better for center, a stack where median is better for center. So here are the 2 piles I have. On the left, I have a pile of things that I think the mean would describe the center better. And on the right, I have things that I think the median would describe the center better. So next, what I want you guys to come up with is why.
I would argue the one that was bell-shaped would be the median.
The bell-shaped median? So let's talk about this. Let's talk about this. What did we notice in our warm-up? When things were evenly distributed, was that the mean a good representation of our data or a bad representation of the middle of our data? Anytime we had symmetry. The mean was good.
Good thing.
So all of these are symmetrical. The mean is the best way. In fact, a lot of times in these, the mean and the median are the same. But on the median side, if it is a little skewed up, okay? See what I mean? I said the joke yesterday, but it's still funny. If it's still skewed up, our mean, what's happening to our mean? It's being pulled. But what happened to the median yesterday when we messed with numbers? Stayed the same. So all these, the skewed ones, we want to use the median to explain the center. The center, the center, the center, okay? So that's just, so far we're explaining the center. The next thing we've got to do is explain how tight is all of our stuff to the center. So, if what are our 2 things that we've used before to explain how variable our data is in terms of respect to the center? Give me one, Greta.
The decimals calculator.
So we used the decimals calculator to do some of these things, but we calculated these 2 different things. Lulu? The MAD, and
Average.
the IQR. The MAD is the average one, yeah. And the IQR. So those are going to explain how spread out our data is compared to the center, and that's what we're going to look at next after I collect your cards back. For looking at variability, I'm going to show you 5 box plots. It's your job then to arrange them in order of least variability to most. Now, one thing I want to point out with box plots, can we even get a mean from a box plot? Can we get a mean from a box plot? No, because we need to add things up, and we don't even know what points are in here. We can get a max and a min, that's it. So, we're using median. Think about the shape of distribution, and then I want you in your group to jot down in your math notebook, which one do you think is the least variable to the most variable? So list them, like rank them. Least variable to most variable, that's your job. So if it has low variability, everything's tight to the center. If it has high variability, it's really spread out. All right, so you and your partner, least variability to most. The only wrong answer is no answer. You can get it wrong and be all right, I got you. So, here's what's awesome. You could look at these and just like try to see how big shapes are and then make a claim. But you don't have to do that. There's a way to math this thing. So if we're looking at variability and we know the median, I'm going to be looking for the interquartile range. That's a number I can get that says my data is this close to the middle. Half of my data is this close to the middle. So let's go and just find all the IQRs. 20 to 60, this one's 40. 30 to 70. Ooh, we got us a tie. 10 to 70. 20 to 70, 50. And 30 to 50, 20. So what these numbers definitively tell me is E has the least variability. Half of my data is within 20. Okay? Next, A and D are tied, so it doesn't matter which order. A and D both have 40 of their data. I kind of maybe would pick A first because the median is more center. But in terms of range, same range of half the data. Next would be C. And last would be B. The bigger the interquartile range, the more spread out my data is. The smaller the interquartile range, the tighter it is. The tighter it is, less variability. The wider it is, the more variability. And I just like, if we have a number, we don't even have to like do it like this number says. It's this variable. So that's when I have the median. What do you notice about the distribution on these? Are they symmetric or skewed?
Skewed.
They're all skewed. And the reason we're going to reference the median is when it gets skewed up, what's the better measure of center? The median. The median doesn't change much when we get skewed. The mean would. So we also need to be able to tell with mean. So here's what we're going to look at with that. We're going to look at this one together. We're going to look at dot plots. Okay? Now, I'm going to show you this slide and the next, so stay with me. What do you notice about the shape of all of these? These ones and these ones. All of them. They're all symmetrical, which tells me the measure for center that is best is what? The mean. And if the mean is the measure of my center, what measure do I have to say how far everything is from that? The mean's my center. What's the measure of how far everything is away from that? Well, interquartile range would be in reference to the median. The MAD. The MAD says, on average, how far away am I from the average? So we want to go least variable to most variable again. So again, how far away from the middle on average? So looking at these, all these have the same average. The average is 10. Which one is the closest to having everything be at 10?
E.
Which one?
E.
Yeah, E. Guess what the MAD is for E? No, it's 0. On average, it's 0 away from the average. Right?
Wait, so mad is like.
On average, how far away you are from the average. Okay, so we don't even need to calculate it right now. We calculate it by finding the average, finding how far away everything is from the average, and averaging that. But E is right on. So looking at C, D, is everything right on those? Nope. And then, so I'm going to let you know, the next one is either A or B. So let's take a vote. Which one has everything closer to 10? A or B? Raise your hand for A. Raise your hand for B. Yeah, so B would be next. We have a collection of a lot of stuff really close to the center. Right? This one has stuff in the center too, but not as much as B. So after B would come A. It's still pretty bunched up. It's bunched up more in the center. And then check out the last two. We're between C and D.
D.
We think D should come next?
Yeah.
Yes.
Okay, yeah, D has some stuff here, and then it's even out here. What's happening with B's on the outside? What's that doing with how far it is from the center?
It's going down.
It's really pulling it far away. So here's the actual measurements. Here's the MAD for all those. There's the 0 where everything is 10, and then check out the MAD for the one that's the least. On average, those are more than 2.5 away from 10 on average. Okay? So this one's pretty close, 2.2. So, to summarize, what you need to know for today is to calculate center, we're going to use the mean or the median. We're going to use the mean if we have symmetric. We're going to use the median if it's skewed. Everybody go with that?
Yeah.
Yeah.
Symmetric is going to be average. Skewed is going to be median. We messed with numbers yesterday and saw how the median didn't change much. Then, if I want to see how my data is, how tight it is toward the center, if I have the median, what should I use to see how tight it is? Which thing deals with the median?
EQ, the interquartile range.
The interquartile range, right? Box. Think about a box plot. Okay. If I have the average, how am I going to know how tight it is?
Mad.
The MAD. And either way, I'm going to get a number, and I can use the number to say it's this spread out compared to this. And it's so nice not to just have to look at it and guess. We can get a number that says yes or no, how variable it is, and then much easier to compare stuff like you did with the card sort. So you're going to do the lesson synthesis as with your partner. You're just going to say which one has greater variability, and I'll go over them in 2 minutes.